The fastest way to make a volcano erupt might be trying to stop it. Imagine scientists discover that a nearby volcano will explode in just a few days. Lava is creeping closer. Entire neighborhoods are at risk. And then someone suggests a solution so insane it almost sounds brilliant. What if we dropped a giant iceberg directly into the volcano? At first, it makes perfect sense. Lava is unimaginably hot. Ice is incredibly cold. One should cancel out the other, right? But here's the strange part. Humans have already tried something similar. Back in 1973, authorities in Iceland launched a desperate attempt to stop advancing lava by pumping enormous amounts of freezing seawater onto it. Not thousands of liters. Not millions. Billions. More than 5 billion liters of seawater were blasted at the lava flow. And yet, the lava kept moving. The cooling effort helped redirect the flow, but it couldn't stop the volcanic power underneath. So a bigger problem demands a bigger solution. What happens if we scale up from seawater to an actual iceberg? And not just any iceberg. A colossal chunk of Antarctic ice. Suddenly the idea doesn't seem impossible anymore. Massive icebergs break away from Antarctica all the time. Some are larger than entire countries. In fact, one famous iceberg that broke off in 2017 was hundreds of thousands of times larger than the lava lake we'd be targeting. So the real question isn't whether we can get an iceberg. The real question is what happens the instant it touches the lava. And that's when things changed. Picture a giant iceberg plunging into a volcanic lava lake glowing at over 1,000 degrees Celsius. The collision would be violent beyond imagination. The first thing you'd see is a gigantic cloud of steam erupting into the sky. Not water. Steam. Instantly. The ice wouldn't even have time to melt. It would transform directly from solid ice into gas through a process called sublimation. But here's where it gets weird. That steam has to go somewhere. And if it can't escape fast enough, pressure begins building at terrifying speed. What happens next changes everything. Instead of cooling the volcano, the iceberg could act like a trigger. A massive steam explosion could rip through the crater. Chunks of hardened magma called tephra would blast into the air. Some pieces could be as large as houses. The very solution designed to save the city might create an even bigger catastrophe. But that's only one possibility. There's another outcome that sounds much safer. Maybe the iceberg cools the lava surface before a steam explosion can happen. Maybe the lava hardens. Maybe the volcano settles down. For a moment, it would actually look like the plan worked. The surface would cool into a strange hardened crust filled with bubbling textures. Mission accomplished. Or so it seems. Because hidden beneath that shell is a problem nobody can see. A problem quietly growing stronger every second. And the volcano isn't finished yet. The hardened lava shell looks like success. The eruption appears contained. The city breathes a sigh of relief. But underneath that crust, volcanic gases are becoming trapped. And that's the twist nobody expects. Volcanoes aren't dangerous just because of lava. They're dangerous because of pressure. And every second those gases remain trapped, the pressure keeps rising. Higher, higher, and higher, until the volcano becomes a giant sealed pressure cooker. And this is where it gets truly terrifying. The iceberg may have cooled the surface, but it hasn't stopped the forces underneath. It's only delayed them. Eventually, the trapped gases find their way out. And when they do, boom. The pressure releases in a violent eruption that can blast apart the top of the volcano itself. The volcano doesn't become weaker. It becomes more unstable. Suddenly, the entire idea flips upside down. The colder the iceberg makes the surface, the greater the chance of trapping dangerous gases below. The plan that looked like a heroic solution turns into the exact thing that makes the disaster worse. And that's the shocking reality. You can't simply freeze a volcano into submission. The energy driving an eruption comes from deep beneath Earth's surface, far beyond the reach of a floating mountain of ice. So if an iceberg can't stop a volcano, and billions of liters of seawater couldn't stop one either, then is there any way to prevent a major eruption once the countdown has already begun? Or are some forces of nature simply impossible to stop?